Good day, Dr. Rosniza. I am Vivian. Today, our group would like to present the outcome of the project-based learning. First and foremost, let me introduce my group members. They are Chu Cui-min, Yong Zifen, Tani Wei, and Liew Mei-ping. So now, let's look at the introduction of this project. Okay, what is control chart? Control chart is actually a tool that used to determine the status of the statistical control system. This tool identifies the variation in processing and it warns if there's any deviation from the tolerance limit detected. So this maintains the process and keep it under the control. Furthermore, these charts also identify the irregular variation in the process by providing the information on process selection and establishment of tolerance limit. Therefore, this also helps to guarantee the standard of the product quality. There are two charts can be applied in monitoring a process such as mean and variation, where the variation chart typically using the range. There are two charts under the control chart such as attribute control chart and variable control chart. For attribute, the product characteristic can be evaluated with a discrete choice such as good or bad, yes or no. Whereas for the variable control chart, the product characteristic can be measured in terms of length, size, weight, height, time, and velocity. This chart is also more detailed and contains more information as compared to that of attribute control chart. There are two samples of chart can be presented for this variable control chart such as X bar and R chart. Let's look at the diagram. Okay, so this diagram depicts the X bar chart and R chart. Besides that, there are three lines involved here, such as the central line, CL and UCL upper control limit, as well as lower control limit, LCL. So if there are any points that exceeded the control limit, a revised control chart has to be created because the process is already out of control. In this project, the variable charts are selected as the device to monitor the output process as they are more detailed and contain more information as compared to that of attribute control chart. In order to apply these theories into real-life sample, we have purchased 5 packs of the Remo Spaghetti to test whether their length conform to the quality. 30 strips of the spaghettis are chosen randomly from each package to measure their length. Besides that, the mean and range of each subgroups are also calculated for the sake of control charts development. That's all from my part. Thank you.
Hi, I'm Chu Cui-min, so I will continue on methodology part. After having a discussions among members, we decide to choose pasta for this work. Since there are a lot of companies that producing pasta in market, we all have decided to use the pasta from San Remo Macaroni's company. As we know, San Remo Macaroni's company produce various types of pasta such as small shell, elbows, boaties, angerheads, and spaghetti. So after a discussion, we all agreed to use the spaghetti from San Remo Macaroni's as our sample. In ensuring that the spaghetti was in different batches, all members bought the spaghetti from different places, and all spaghetti had different production date. This table shows the purchase locations and production date of the spaghettis. The first replicate is bought at Liew Supermarket, Bukit Mertajam, Penang, and the production date is 18 December of 2019. The second replicate is bought at Tesco Selatan, Sungai Petani, Perak. The production date is 21st October of 2020. The third replicate is bought at Tesco Extra, Sungai Dua, Penang. The production date is 22nd September 2020. The fourth replicate is bought at Aeon Ipoh Station 18, Ipoh, Perak. The production date is 20 October 2020. The fifth replicate is bought at Mercato Gurney Plaza, Georgetown, Penang. The production date is 27 October of 2020.
Good day, doctor. My name is Liew, and now I would like to present the step for measuring the samples. Okay, first of all, take a 30 cm ruler, wash it with dishwasher, and then wipe it with a clean cloth until it is dry. Next, open and cut the spaghetti package. Take out 20 samples from it. In this step, avoid to take the sample from one place and should be taken randomly from the package. Then, put aside the 20 samples. Put a clean ruler on the flat table and start to measure the sample's length. When measuring, we measure the length from the tip to the end of the sample and record the reading. And this step was repeated for all the 20 samples. Lastly, a new replicate was repeated for all the steps above until finished for 5 replicates. Okay, that's all for my part. Thank you.
A very good day I bid to doctor and everyone. My name is Yong. Today I would like to present about the result of this project. Okay, now we have constructed a table and we take the spaghetti as our samples, and based on this table, and there consists of 20 of the samples, and there have 5 replicates, and each replicate consists of 20 of the samples. So first we need to calculate for the summation of the x. So we are by using this formula, which is total up all of these value, and then we will get 137.1, and this is the summation of x. And after that we need to calculate for the x bar, which is by using this formula, which is summation of x that we have calculated just now, and then we substitute inside and divided by n, which is 5, because we have 5 replicates, and then we will get the value, which is 25.42 cm. And after that we need to calculate for the r, which is the difference between the x maximum and x minimum, which is by using this formula. So for the x maximum is we find from here, we need to find for the largest value, which is 25.6 from here, and then after that we need to find for the lowest number, which is 25.1, which is the lowest, which is also known as the x minimum. And after that we need to minus both of them, and then we equals to 0.5 cm. And after that we need to calculate for this one, x double bar. This x double bar is also known as the central line in the x bar chart, and later I will show you in the graph. And for this one, we need to total up all of these value and then divided by 20, the total sample, and then we get 35.2 cm. And after that we need to calculate for this one, the r bar, which is by using this, by adding up all of these value and then divided by 20, and then we will get 0.965 cm. After we constructed a table, now we need to draw for the x bar chart. So for the x bar chart, it consisted of the 3 main components, which are the central line, upper control limit, and lower control limit. And for the first one, to determine the central line for the x bar chart is by using this formula, which is x double bar, which is called the central line, equals to summation of the x bar divided by m, which is equals to 25.2 cm, which is the central line in the x bar chart. Well, for the second one is used to determine the control limits for the x bar chart. So for the control limits, which is divided into two types, which are the upper control limit and also the lower control limit. And the upper control limit, the formula is equals to x double bar plus a2 times r bar, and the value we get is 25.7568 cm. Well, for the lower control limit, which is equals to x double bar minus a2 times r bar, and the value we get is 24.6432 cm. Well, for the r bar, how do we calculate for the r bar? Is by using this formula, which is equals to summation of r divided by m, and then we will get 0.965 cm, and then we substitute inside here, and also the upper control limit. Well, for the a2, which is based on the table constant, and I will show you now. So this is the table that we refer, and then as we have 5 replicates, so we need to see the fifth one, and then based on the a2, and then we will get a value which is 0.577, and then we substitute inside here. And then also for the upper control limit, also the same, and then we will get the value that we want. And after we found the central line, the upper control limit, and also the lower control limit, and then only we can plot for the x bar chart. So this is the x bar chart that we have drawn, and there are 3 main lines, which are the upper control limit, lower control limit, and also the central line. So as I explained just now, this one, we are by using this formula to calculate the upper control limit, and then we get the value is 25.7568. Well, for this one, which is the central line, we are by using this formula, and then we get the value is 25.2 cm. Well, for the last one, which is the lower control limit, we are by using this formula, and we will get a value which is 24.6432 cm. And after we draw these 3 main lines, and then we need to plot for the 20 of the sample in this graph. So the blue color shows that the 20 of the samples, and then it can be observed that this graph is in control, which means that the process mean is in statistical control, as there is no point of the sample which is out of the limit, out of the control limit, and also out of the upper control limit and also lower control limit. So it says that the graph is in control. So thank you, that's all for my part.
Hi everyone, my name is Theng. I would like to continue present the part of R chart. For the R chart, the first step is to determine the center line for R chart. By using the formula, the center line value is 0.965 cm. Then, for the next step, the upper control limit and lower control limit are calculated by using the formula. The D3 and D4 value that used in the formula are referred from the appendix of the subgroup set of 5, which the D4 value is 2.114, while the D3 value is 0. Thus, the upper control limit value is 2.04 cm and the lower control limit value is 0. This is the R chart that plotted with the center line value, upper control limit and lower control limit. From the graph, it can be seen clearly that the subgroup of 4 is exceed the upper control limit. Thus, it can be said that the R chart is out of control. In order to find the new value for the revised control limit, a new center line is determined. By using the formula, we get the new R value of 0.8789 cm. The variance are then calculated by dividing the new center line value with D2. From the table 2, the D2 value for subgroup set of 5 is 2.326. Thus, the variance we get is 0.3779 cm. Next, by using the formula, the value of upper control limit and lower control limit are 1.8585 cm and 0 respectively. The D1 and D2 value that used in the formula are referred from the table 2 with the subgroup set of 5. In this revised R chart, the exit upper control limit point, which is the sample point number 4 in the previous R chart, are eliminated. Then the revised R chart are plotted with the new range of centerline, upper control limit, and lower control limit value.
Hi, it's me, Chu again. So I will continue on conclusion part. In conclusions, this project aims to study the statistically method for quality assurance and quality control. Based on the result obtained, the X-bar chart shows that all the points are within the control limits. Nevertheless, one of the points in our chart exceeds the upper control limit. Revise of centerline and control limits for determine new R-bar is done and new R chart is constructed. So that's all from us. Thank you for watching and goodbye.